Hello everyone, in today's video we're going to be doing paper 1 multiple choice of May-June 2018 chemistry for GCE O Levels 5070 paper 1-2, paper 1 variant 2. So let's start with question number 1. A student wants to show that the rate of reaction, between calcium carbonate and dilute hydrochloric acid doubles every 10 degrees Celsius in rise in temperature. The method the student uses to measure the volume of carbon dioxide. Okay, the method the student uses is to measure the volume of carbon dioxide released. Because there's a carbonate, there will be carbon dioxide that will be released in the reaction. The student has a Bunsen burner and a gas syringe. What other essential apparatus must the student use? So obviously the student needs a clock. So the options with clock will be selected. So option A will be cancelled. Next, the student will be needing a burette. Why will the student be needing a burette and also a pipette? Because we have hydrochloric acid and we have calcium carbonate. So all carbonates are soluble except sodium, potassium, and calcium. So this is also a soluble carbonate. So one will be given at a fixed amount and the other will be given slide by slide to measure the rate of reaction depending on how much it is released. So for number 1, the answer will be C. Which mixture can be separated into its compounds by adding water, stirring, and filtering? So water will act as a suitable solvent, and then stirring and filtering. So one of the compound is not soluble. So calcium carbonate, it is soluble, and sodium carbonate is soluble. So option A will be cancelled. Magnesium and iron, both of them are not soluble. So it will be magnesium is soluble and iron isn't. So it will not be reacting. There will be no reaction. Sodium chloride is soluble, and then copper to sulfate is also soluble. So for number 2, option C will also be wrong. Sulfuric acid also soluble. Hydrochloric acid is also soluble. So this is also wrong. So C and D are confirmed incorrect. Calcium carbonate is soluble and sodium carbonate is soluble. So this won't be the answer. So the answer will be B. Magnesium will react with water to form magnesium hydroxide, which is a soluble liquid. Iron only reacts with steam. Only reacts with steam. So this will remain insoluble. It does react very slowly with cold water, but it will not dissolve. Which row gives correct tests to identify both ammonia and sulfur dioxide? So identification of ammonia, it is an alkaline gas, meaning it will be a damp red litmus paper. So alkaline will be red to blue. So option A and option B will be cancelled. Test to identify sulfur dioxide. So sulfur dioxide, it will be this will be a test. This is a reducing agent. So it will be the test with potassium permanganate and potassium permanganate. So for number 3, the answer should be to identify the ammonia should be damp. So identifying. Okay, so the answer will be C. Okay, let's move on to the next question. Two gases, ammonia and hydrogen chloride. Ammonia and hydrogen chloride are an equal pressure are allowed to enter the apparatus shown. After a time, a white solid forms on the inside of the tube. Okay, which statement explains why white solid forms in the position shown? Ammonia react to form solid ammonium chloride. Yes, ammonia diffuses faster than hydrogen chloride. So ammonia diffuses faster. Okay, so we actually have an error for the first question. The mistake that I made is assuming this will be a soluble carbonate. Only group 1 carbonates are actually soluble. This is an insoluble carbonate. So burette and pipette won't be an option. So options with pipette and burette will be cancelled. So the correct option is going to be B. For this one, it will also be the same. Both magnesium and iron do react with water, but iron reacts very slowly. And we don't want any reaction with iron. We want one of the compounds to be unharmed. And we must filter the solution. So the answer will only be A. And magnesium hydroxide is actually a solid. Only group 1 oxides and hydroxides are soluble. Only group 1 oxides and hydroxides are soluble. Okay. Ammonia diffuses faster than hydrogen. If ammonia were to diffuse faster compared to hydrogen chloride, yes, the solid would have formed here because ammonia would travel further. So yes, ammonia has a lower relative molecular mass compared to hydrogen chloride. So if it has a lower molecular relative mass, it will have faster rate of diffusion. So yes, this is also true. So answer is A, 1, 2, and 3. The atomic number cerium C is 58. A Ce4 plus ion has 140 nucleons in its nucleus. So Ce 140. And the atomic number is 58. So this is turned into a Ce4 plus ion. So here the proton will be 58. The neutrons will be 140 minus 58. So if we do 140 minus 58, we get 82. So 82. And for electrons, it will be 4 less compared to protons. So it will be 54. So 54, 54. Neutrons is 82, 82. And protons is 50, 58. So for number 5, the answer is going to be A. The diagram shows the arrangement particles in 3 solids, X, Y, and Z. These 3 solids are krypton, potassium, and sodium. Okay, which will correctly identifies, okay, so krypton is a noble gas, potassium is a metal, and sodium chloride is ionic. So this is definitely sodium chloride. And this definitely is potassium. So X is sodium chloride and Y must be potassium. That means Z has to be krypton. So this will be our answer, D. Which statement about solid calcium chloride is correct? It conducts electricity. Solid calcium chloride. It is ionic. Ionic compounds do not conduct electricity when they're solid. It has a low melting point. No, ionic compounds always have high melting point. It has ionic lattice structure. Yes. It is insoluble. No. All ionic compounds, most ionic compounds are soluble in water. And this is a calcium salt and it's chloride. So obviously all chlorides are soluble except silver and lead. These chlorides are insoluble. So the answer is going to be C. Ethane, 2H6, C2H6, and ammonia are covalent compounds. A dot cross diagram for these compounds are shown. Which statement is correct? A molecule of ethane contains twice as many hydrogen atoms as a molecule of ammonia. So 1, 2, 3, 4, 5, 6 hydrogen. 1, 2, 3. So 3 hydrogen. So 6 divided by 3, yes. So 1 is the correct statement. So option D can be cancelled. An unreacted nitrogen atom has 5 outer electrons. So from here we can see 1, 2, 3, 4, 5. So if we draw the dot and cross diagram for N, 1, 2, 3, 4, 5. And from that, if we go ahead and add the hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Oh, so I actually forgot. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. So 2 over here. Oh, we'll have another hydrogen which will be reacting. So yes, we can see that nitrogen does have 5 outer electrons. So statement 2 is also correct. In a molecule of ethane, the bond between the carbon atom is formed by sharing 2 electrons, one from each carbon atom. So we have ethane. So ethane is going to be drawn like this. And as we can see, one pair, then we have one from this carbon and one from this carbon. Then we have one over here, one over. So no, not bond between carbon by sharing 2 electrons. No, we only share 1 electron. So option 3 is incorrect. So 3 is incorrect, 3 is incorrect. Answer is only 1 and 2. So let's move on to question number 9. So let's move on to question number 9. Okay, sorry. Over here, if we actually take a look in a molecule of ethane, the bond between the carbon atoms. So right here, the bond between carbon atoms. So if this were the carbon, so carbon has 4 of them. So one will go over here. So if you actually draw the diagram, I'm going to draw the diagram over here. So if you actually draw the carbon, and if we draw a hydrogen over here, we're not going to draw all of them, we're just going to draw 2 carbon. So 1 electron over here, 1 electron over here, 1 electron over here, and then we have one electron over here, the other electron over here. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. In the molecule of ethene, the bond between the carbon atoms is formed by sharing 2 electrons, one from each carbon atom. So each carbon atom is sharing 1 electron. So yes, option 3 is actually correct. The answer should be A. Which statement about the structure and bonding of metals is correct? A metal lattice consists of atoms and a sea of electrons. Okay, this could be correct. Electrons in a metal move randomly through the lattice. Okay, so electrons move in a lattice. Now, this statement is actually incorrect because the metal consists of atoms. It consists of positive ions, not atoms. Metals are malleable because the particles present are mobile. No, they just slip and slide over each other. The ions in a metal move when positive and negative electrodes are attached. The ions in a metal do not move when positive or negative electrodes are attached. So the answer is going to be B. When 1 volume of gas R reacts with exactly 5 volumes of oxygen, it forms carbon dioxide and water only. What is R? So that means we cannot change the values 1 and the values 5. So let's see if we can balance them. So you have carbon dioxide and water. So if you want to balance this, so we have to put 4 over here and we have to put 5 over here. So the carbon and hydrogen are balanced, but let's see if oxygen is balanced. So 4 times 2, which is going to be 8 plus 5. 9, 10, 11, 12, 13 oxygen. And over here we have 5 oxygen. So no, the first option is incorrect. Okay, let's move on to the second one. So ethane. So 1C2H6 plus 5O2 will give us CO2 plus H2O. Again, we're going to try to balance it. So we have 2 over here, and you've got 3 over here. And the total number of oxygen will be 4 plus 3 is 7. But over here, the total number of oxygen is 10. So the answer is neither A or B. Now let's take a look at methane. Let's take a look at methane. Let's draw the methane here. CH4 is also 1 plus 5O2 is going to give us CO2 plus H2O. So now let's go ahead and try to balance it. 1 and 2. In total, we're going to have 2 plus, so we have 1 over here, 2 oxygen plus 2 oxygen. We're going to have 4 oxygen. But over here, we have 10 oxygen. So this is also incorrect. So the correct option should be D, but let's just go ahead and check our answer. So we have 1C3H8 plus 5O2 going to give us 3 carbon dioxide molecules plus 4 hydrogen, making carbon and hydrogen balanced. Now we have 6 plus 4, yes, 10 oxygens. Over here we also have 10 oxygens. The relative molecular mass of a compound is 166. What is the possible molecular formula of this compound? Okay, so to find the molecular formula. Now first, we have to remember that the molecular formula of the compound is going to be the empirical formula to the power of n, where n is the relative molecular formula by mR. Okay. So first of all, if we actually take a look at that, the empirical and molecular formula of this compound will still remain the same. So if we actually go ahead and do 166 divided by 4 times 12, let me go ahead and correct that. 4 times 12 plus 3 plus 2 times 16. C4H3O2, and if we divide it by 166, 4 times 12 plus 3 plus 2 times 16, it's going to give us 2. So the final answer is actually C8H6O4. This is not the molecular, not the empirical molecular formula that's matching. Okay, now we can deduce a molecular formula for this one. It's going to be H2O2. C3H2O2. If you do the same over here, 3 times 12 plus 2 plus 2 times 16, we can go ahead and do it. Okay, so if we actually now do the calculation, 166, 3 times 12 plus 2 times 2 times 16. Oh, we're going to get decimal 2.3. So if you actually go ahead and multiply this, let's say by 2, we're going to get 2.3. So you're going to get C7 4 times 2.3, and O is going to be 4 times 2.3. So it's going to be 8.8. So this is definitely not the correct answer. Let's try option D, since D is being the correct every time. So let's try option D. C4, we're again simplifying it, H3O2. Okay, so let's go ahead and try using the formulae. So it's going to be 166, 4 times 12 plus 3 plus 2 times 16. So 166, we're going to have 4 times 12 plus 3 plus 2 times 16 is going to give us equal to 2. So if you multiply this by 2, it's going to be 8, 6, 4. It matches exactly. So this is going to be your final answer. A mass of 63 grams of potassium permanganate is needed to complete the oxidation of 23 grams of ethanol under acidic conditions. How many moles of ethanol can be completely oxidized by 1 mole of permanganate under these conditions? So we have C2H6O plus KMNO4. Now we do not need to know the products because we only need information about the reactants. Ethanol can be completely oxidized 1 mole of potassium. So 1 mole. So the mole is given. So we don't know the moles of ethanol in the reaction, but we do know that this is going to be 1 mole. Okay, so the moles is given to us. So now we know the mass of potassium permanganate, KMNO4. So we can find the moles easily that we need to, or the calculated mole. So we first need to find the AR of potassium. So what is the AR of potassium? From the periodic table, we can see that potassium's AR is 39 plus manganate is 55, or manganese, plus 4 times 16. So if you actually do this calculation, 63 divided by 39 plus 55 plus 4 times 16 should be giving us 0.399. So now we're going to be doing the molar calculation, which is X is to 1, which we do not know. And we are also given the information of ethanol. So before we do that, we also need to find information about ethanol. Again, moles is going to be mass divided by ethanol is going to 2 times 12 plus 6 plus 16. So what is going to be the answer? 23 divided by 2 times 12, which is 24, plus 6 plus 16, which is going to be 0.5. So now we can do X times X is to 1. Let's consider ethanol X and potassium permanganate, which is 1 moles. And then we know the moles of ethanol. We also know the calculated moles of potassium. Oops. Okay. Then we're just going to be going ahead and cross multiplying. So X is going to be 0.5 divided by 0.399. 0.5 divided by 0.399. So from this, my calculated answer comes to 1.25. So my final answer is going to be 1.25, which is D. Okay, the diagram shows an electrolysis experiment using inert electrodes, which could be liquid Y. Okay, so liquid Y. So over here, we can see that the gas is approximately in a ratio of 2:1. That means we can say that this is going to be the hydrogen-oxygen gas ratio, which we have learned from syllabus. It's going to be always 2:1. And over here, we have no gas. Okay, so this is before the electrolysis. So that means in the negative electrode over here, the negative electrode or the cathode, we must have hydrogen dissociated, and over here we must have oxygen dissociated. So let's take a look at the reactants. Aqueous copper to sulfate. So at the cathode, for aqueous copper to sulfate, you're going to have copper, and at the anode, we're going to have oxygen gas. So this is wrong. Concentrated aqueous sodium chloride. So at the cathode, we are going to be having hydrogen, but this time at the anode, since it's concentrated, we're going to be having a chlorine gas. So it's going to be wrong. Ethanol cannot be electrolyzed. So the only answer is dilute sulfuric acid, because since it's dilute, in the cathode we're going to have hydrogen, and the anode, since it's an acid, the compound is H2SO4, in the anode we're going to have oxygen. So for number 13, the answer is going to be C. Let's move on to number 14. Magnesium can be produced by electrolysis of molten magnesium chloride. What are the products formed in the anode and at the cathode during electrolysis of molten magnesium chloride? Okay, so molten magnesium chloride, MgCl2, which is liquid. So this is going to be the cation at the cathode. We're going to have magnesium. This is going to be the anion at the anode, which is going to be the chlorine gas. So chlorine, and then we are going to be having, oh sorry, just tick the wrong, here it is. At the anode, we're going to be having chlorine. Cathode, we're going to be having magnesium. So the answer should be B. The diagram shows apparatus that can be used to extract aluminum from its ore, which is bauxite or aluminium oxide. Okay, what is J, K, and L? So obviously J is going to be the J is going to be the anode, where we're going to be, so this is going to be the positive electrode, anode, because the negative ions is going to go there. Okay, then we are going to be having K, which is going to be bauxite, the ore, and finally we're going to be having aluminum. So positive electrode, then we're going to be having A, which is going to be aluminum. Now obviously if we just had aluminum oxide, this wouldn't be the answer. It must be dissolved in cryolite to lower the melting point to 900 degrees Celsius, or else the melting point is going to be even higher. So for number 15, the answer is going to be D. A reaction is exothermic. Which diagram shows the correct energy profile diagram for the reaction and the correct enthalpy change? It's exothermic, meaning the product is going to have less energy. So option A and option B can be cancelled. Next, we must have the positive enthalpy change. So for a energy profile diagram graph, right here, if this is the reactant, this is the product, the enthalpy change is always from the reactants to the products. So for option C, the arrow is a positive enthalpy, which is going from the products to the reactants. It's going to be an incorrect option. So the answer is going to be D. Which fraction of petroleum crude oil is used as fuel in aircraft engines? From theory, we learned this is kerosene. Gasoline is normal gas that's used in household. Naphtha is for chemical stock, and bitumen is for roads. The equation of photosynthesis is shown. Which statement of photosynthesis is correct? It says it has a negative enthalpy change. No, photosynthesis is endothermic, meaning it has a delta H positive. It is catalyzed by the presence of yeast. This is also wrong. The products of photosynthesis are oxygen and starch. So right here, this is starch, yes, and this is oxygen. Starch, or you can basically say glucose. It occurs in green leaves. So the answer is going to be, so yeah, it does occur. So it's actually not starch, it's going to be glucose, not starch, because it's the basic product and then it's converted into starch using the sink of the plant tissues and the float. Okay, compound X reacts with acid to produce sulfur dioxide gas. The sample of X is placed in a flask and acid is added. Okay. Sulfur dioxide is produced and collected in a volume and measured at given time. The graph is plotted. Which statement about this experiment is correct? The gas can be collected by displacing water from measuring cylinder. No. Sulfur dioxide, no, it cannot be used in a displacement of water because the gas is heavier compared to normal air, and if you try to displace it in water, it's just not going to go up. So it's not going to be displaced. The mass of the reaction flask and its contents decreases, the reaction proceeds. Yes, since a product escapes. The rate of reaction increases to no, because we can see that the graph becomes flat as time proceeds. The reaction is still proceeding up after 8 minutes. So as we can see right here, it's 8, or approximately that's 8, and the graph is flat, so it is not proceeding. So the answer is going to be B. Which reaction involves oxidation and reduction? Chlorine gas reacting with potassium iodide. So this is a reducing agent. This is also a reducing agent. So number 20. So Cl2 is reacting with Ki. So it's going to form KCl plus I2. So chlorine is being reduced. This is being oxidized. So 1 is the correct option. Next, we have dilute sulfuric acid reacting with magnesium. So H2SO4 plus Mg is going to give me magnesium sulfate plus hydrogen gas. So over here, this is being oxidized, and this hydrogen over here is being reduced. So yes, why is it being reduced? Because this was a plus positive charge, and now it has a net charge or net oxidation state of 0. Dilute hydrochloric acid reacting with aqueous sodium hydroxide. So this is a neutralization reaction. So this is not a redox reaction. So the answer is going to be B. Nitrogen reacts with oxygen to form an equilibrium reaction. Which reaction in equilibrium? Which statement is correct? When the reaction is at equilibrium, the constant nitrogen present a change in time. No, a equilibrium reaction means that rate equal to rate. So the rate should be same. The forward backward direction is taking place at the same rate. Yes, the forward releases heat energy. So over here it's an endothermic, so temperature is less, so it doesn't release heat energy. There are more molecules on the left hand side of the equation compared to the right. So if we take a look at the equation, we have one, so 2 molecules, and over here we have 2, which is also 2 molecules. So this is actually equal. So this is incorrect. So the answer is going to be B. Lead 2 oxide reacts with dilute nitrogen, neutralizing the acid. Lead 2 oxide also reacts with aqueous sodium hydroxide, neutralizing the alkali. So it reacts with both alkali and acid, meaning it is an amphoteric oxide. Reacts with both acidic and alkaline solution. So the answer is going to be C. Which pair of reagents are most suitable in a laboratory for the preparation of copper 2 chloride, which is soluble? Soluble can be prepared by soluble plus soluble or soluble plus insoluble. Here this is a titration, and here it's going to be neutralization. Since we have copper, we cannot prepare it by titration, or we can, and we have chlorine. So we can use HCl, we can use CuNO3, we can also use CuO, CuOH, we can use anything. So only copper is never going to work. Copper to nitrate and sodium chloride are salts. It's never going to work. It's a salt. Copper, so it's not going to work. So the only option is D, using a neutralization reaction. The compounds shown can be used in nitrogen as fertilizers. Which compound has the lowest percentage by mass of nitrogen? So over here we have 2 nitrogen. The MR is 60 into 100. So 2 times 14, which is 28 by 100. So we have 46.67%. Next, we again have 2 nitrogen. Total MR is 132 into 100. It's going 28 divided by 132 into 100. It's going to be 21.21%. Next, we have 3 nitrogen with a 149 MR into 100. So it's going to be 3 times 14 by 149 into 100. It's going to be 28.19%. And finally, we have 2 nitrogens. So 2 times 14 divided by 18 to 100. So 2 times 14 divided by 80 into 100, which is going to give us 35%. So we have to find the nitrogen with the lowest percentage, so which is going to be this one right here. This has the lowest percentage, so this is the answer. The diagram shows 3 steps in the manufacturing of sulfuric acid. Where is the catalyst used? Sulfur to sulfur dioxide, so there is no catalyst. Sulfur dioxide to sulfur trioxide, we use vanadium 5 oxide catalyst, since this is a reversible reaction. So we're going to put 2 over here, which is going to make it 6. So we put 2 over here. So the answer is going to be this step. In step R, we only use oleum and water, so this is not going to be an answer. So the answer is going to be C, which is Q only. So this was our answer, step Q. Okay. Indium of proton number 1 is in group 3 of the periodic table. Antimony of proton number 3 is in group 5 of the periodic table. Which statement of comparing indium and antimony is correct? So it's in group 3. So indium is more metallic, then antimony is more non-metallic. So antimony has more metallic character. Nope. So option B is antimony has more metallic character and more valence. Okay, so more metallic character. So indium has more metallic and more metallic character. Antimony has more valence electrons and more than antimony. Okay. So we need to look at the periodic table for this one. So indium is in group 3. So indium is in group 3 and 1, 2, 3. Let's see. 1, 2, 3, 4. So it's in the 4th period. So indium has 4e minus valency. And group 5 of the periodic table, which is antimony. So if you go to group 5 over here of the periodic table, so indium has more metallic character and more valence electrons. Indium has more and antimony has more valency electrons per atom. So it says per atom. So we're doing a comparison over here. So from group 3 and group 5. So antimony is in 1, 2, 3, 4. So antimony is also in period 4, so it also must have a so we're actually counting the shells. I'm really sorry. So the valence electron is dependent on the group. So 3Ve minus and 5Ev minus. So indium has more metallic character and more valence electrons. No, indium has less valence electron compared to antimony. So antimony has more valence electrons. Since it's in group 5, that means it has 5 outer shell electrons compared to indium, which is in group 3 and it has 3 outer shell electrons. The positions of 4 elements are shown in outline in periodic table. Which element is a solid non-metal? It is obviously going to be this right here, which is iodine, because this is going to be group 3, 4, 5, 6, 7, 8. 3 elements, each show oxidation states of +2 and +3, to which the periodic table T does these elements belong to? So this is variable oxidation states, meaning it's a transition metal. Brass is an alloy. Which statement about brass is correct? It contains a sea of electrons. Yes, it contains positive negative ions. No, not positive and negative ions, only positive ions. It is a compound of metal and non-metal. It's not a compound, it's just a physical mixture. So this is not correct. It is a compound. Again, it is not correct. So for number 29, the option is going to be A. Copper to oxide reacts with carbon when heated. Okay, which statement about this reaction is correct? As you can see, copper is being from +2, it's going to 0. So copper to oxide is no, it's not a reducing agent. Copper to oxide is oxidized. Nope, it is reducing it, and this is oxidizing itself because it's gaining oxygen. Carbon is gaining oxygen. So yes, carbon is a reducing agent. The diagram shows a cell that can be used to extract metals from its oxides. Molten aluminum oxide, copper to oxide, lead to oxide, and magnesium oxide are each electrolyzed in separate cells. Each cell receives the same number of electrons. Which statement is correct? All metals can also be extracted from... No, not all metals. Anode and cathode should be made of the metal being extracted. Nope. Pure metal is always produced at the cathode. The anode breaks down, and yes, the cathode. The same mass of each metal is formed. No. So the correct option is going to be C. The anode breaks down, and the pure metal is deposited at cathode. Now, iron is obtained in blast furnace from the ore hematite, which process takes place in blast furnace. So, calcium carbonate is used to remove the acidic impurities. No, calcium oxide removes the acidic impurities, but calcium carbonate decomposes to the calcium oxide. So this could be a correct option. Coke is reduced to carbon dioxide. No, it's not reduced to carbon dioxide. So Coke plus carbon dioxide is going to form carbon monoxide. Hematite is oxidized from carbon monoxide. So it is not oxidized. Hematite undergoes thermal decomposition. No, it's a redox reaction that occurs where iron is reduced. So the answer is going to be A. Aircraft manufacture requires a metal that has relatively low density, which can be aluminium, which is also fairly less reactive, resistant to corrosion. Also, aluminium. Which of these does aluminium satisfy? Both 1 and 2. Which pair of gases both are non-acidic? So ammonia and methane. No, these are alkaline, and if we talk about methane, it is also not acidic. Carbon, no, this is an acidic gas. Nitrogen dioxide is also an acidic gas. It is also an acidic gas. So the only option is A. Seawater is desalinated to make it drinkable. Which is the main substance removed from desalination? It's going to be sodium chloride, or basically salt. Which diagram shows a branched chain isomer of butane? So we have to draw butane first. 3, 4. So we have butane right here. Okay. So now 1, 2, 3, 4. So it has, let's first denote this. 4 carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Oh, so all of them are 10 and 4. So over here we also have 10 and 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now this is not a branched isomer since the long chain already has 4 of them. So option C can be omitted. Now let's look at this one. So we have 1, 2, 3, so 3. So this could be a branched isomer. Over here, again, the long chain is 4. So this is also not a branched isomer. Over here, again, the long chain can be easily attached with 4. So the long chain remains 4. Over here, the long chain remains 3, which means it is actually 2-methyl pentane. So this is our correct answer, A. The straight chain alkane undergoes addition reaction with bromine. So addition reaction, C4H8 plus Br2. So when it goes addition reaction, it's going to form the exact same thing. Or basically 1, 2, 3, 4. 1, 2, 1, 2. So it's just going to add the bromine here and add the bromine here. Basically, the double bond breaks. Okay, so now let's take a look. The bromine are very far apart from each other. So this cannot be a correct answer. Again, the bromine is closer to each other, so B could be a correct answer. The bromine is very far apart from each other. So this is a wrong answer. And there's only one bromine over here. So this, and this is a wrong option. The only option is this, because now if we actually draw this diagram-wise, CH, so we actually have to draw it like this. So over here we have the bromine, and the original one would have looked, well, without the bromine, the original one would have had a double bond over here. Okay, so we have just 3 more questions left. The diagram shows structure of oxalic acid. Which alcohol is oxidized to form oxalic acid? So let's try to see. So we have one acid group over here. So we have acid group and we have one acid group. So we need 2 alcohol groups. So we have one alcohol group and one alcohol group. One alcohol group, one alcohol group. So this is wrong, this is wrong. Now take a look. We have 2 carbons, C2. But over here we also have 2 carbons, but here we have 1, 2, 3, 4. We have C4, which is not possible. So the answer is going to be C. Some properties of compound G are listed. It reacts with potassium carbonate to produce carbon dioxide. Yes. Okay, fine. What is a possible identity of, okay, potassium carbonate? So metal carbonate. It reacts with ethanol to produce sweet, so it's esterification. It reacts with sodium hydroxide alkali to form salt, which is a neutralization reaction. All 3 relates that this compound right here is an acid. So the correct answer is going to be ethanoic acid. Last question. The diagram shows the formula of nylon. Which could it be made from? So consider that this is actually a block of hydrocarbons. So basically nylon was made from a dioic acid plus a diamine. By losing this hydrogen and the acid losing this hydroxide group to give a additional water. So we need to make this into a into a shorter formula, which is going to be COOH plus NH2 and NH2. So this part is correct. Now we have to also take a look at this inside value because we need to match it over here. So with COOH we must have CH2O4, this one right here. So which one is going to be the correct value? This and this. And for the amine group we must have C2H6. So which one is the correct value? This one and this one. So for both, the correct option is going to be C, since both of them match. So anyways guys, that's going to do for this paper, the chemistry multiple choice paper. I'm going to leave a link in the description so that you can download this solved paper, and hopefully I'll be catching up in a different video next time. See you then. And make sure to put it in the comments, what would you like to see next solved, or your next paper that you wish to be solved. Other than this, see you next time.